Hey, it's me again, Digital Mr. Triola. Chris, are they ready for their first lesson out of the math book today? Oh, okay, good, they are. All right, so anyways, kids, what you're going to do is you're going to open your book to topic 1, lesson 1. It will be on page 6, and you will be working with expanded form, okay? So why don't you take a moment right now to open your book to page 6, topic 1, lesson 1. All right. Are they ready to go? Mr. Triola, are they ready? Yeah? Okay. All right, so anyways, you'll notice that in your book, they start off by giving you the topic of the lesson, which is exponents. And then they give you a question, and it says to us, how can you write a number using exponents? Well, exponents are those little numbers that sit on the shoulders of another number and give that number a lot more value, okay? So exponents are a way of writing very big numbers only using a few digits. We do this because it helps us make things easier, and it saves time, and that's why we use exponents. But we're going to talk a little bit about exponents in exponential form, okay? Now, it says, how can you write a number using exponents? Each place in a place value chart has a value that is 10 times as great as the place to the right. Okay, so, the tens are 10 times greater than the ones. The hundreds are 10 times greater than the tens. The 10,000s are 10 times greater than the thousands. So you get this pattern of increasing by multiples of 10. Okay? Use this pattern to write 1 million as repeated multiplication. So we're going to look at the next page, and we're going to talk about writing 1 million as repeated multiplication by tens. Chris, you want to ask some questions right now? Oh, okay. Let's ask a question. Which place in the place value chart is 10 times greater than the 100,000s place? Which place in the chart, in the place value chart, is 10 times greater than the 100,000s place? Okay, there's the 100,000s place. Think of that pattern as increasing by multiplying by 10, okay? So which place would it be? Anybody know? Chris, you want to pick somebody? Anybody have their hands up? Okay, here it is. The answer is, did they get it? Here we go. The millions place. 1 million, okay, the million. So if you have 10 100,000s, you will get 1 million. All right? So it is 10 times greater than the millions are 10 times greater than the thousands place. Okay, how about this question? Which place in the chart is equal to 1/10 of the thousands place? 1/10 of the thousands place. Here's the thousands place. So what would you need 10 of to make 1,000? Anybody know? Any hands up? All right. Okay, here we go. Confirm the answer or give the answer. The hundreds place. So 100 is a tenth of 1,000. 100 is a tenth of 1,000. Okay, so anyways, our question is, use this pattern to write 1 million as repeated multiplication, okay? It's all zero, so we're going to be working with 10 times 10 times 10. How would we get to 1 million multiplying by factors of 10? How many factors of 10 would we need to get to 1 million? A hint is how many zeros there are. So then we go on and we see that we have 1 million, but we want to express 1 million as multiplication by 10. So 10 will be used as a factor 6 times. Now notice that there are 1, 2, 3, 4, 5, 6 zeros in 1 million. Okay, and notice that it takes 10 times 10 times 10 times 10 times 10 times 10 to equal 1 million. In other words, you would have 1, 2, 3, 4, 5, 6 zeros in order, 6 zeros from 6/10 to equal 1 million. So that's how you would use 10 as a factor 6 times to get a million. Now the other thing that it tells you is that you can write the repeated multiplication of a number in exponential form. That means you can write it using exponents. So basically, instead of writing out all of those zeros or all of those tens, you're going to use an exponent, and you're going to put it on the shoulder of 10. So in this case, we see that 1 million is equal 10 to the 6th power, okay? So what you have is you have 10 to the 6th power. And that means, that 6 means that you're going to multiply 10 times 10 6 times. That's what it means, okay? And we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 10 to the 6th, okay? And you can see that it's a lot easier to write all of that in exponential form, okay? It looks like X's and O's. Holy king, huh? X's and O's. Anyways, so the base is the number that is repeatedly multiplied, okay? So 10 is the base, and it is going to be repeatedly multiplied, okay? 10 is the base of the number, okay? It is repeatedly multiplied. The exponent or power is the number of times the base is used as a factor. So we have the base of 10 being used 6 times in multiplication. So it's used 1, 2, 3, 4, 5, 6 times. That's why we say that 6 is the exponent, okay? So remember a couple important things here, okay? One important thing is to remember that exponents allow us to write very big numbers using only a few digits and saves us time. The other thing to remember is that this is the what? Altogether, it's the base. Yeah, the base. This is the base. And the 3 is the, anybody? The exponent, okay? I never know if anybody's answering anything out there, do I, Chris? No. Is the exponent. And the exponent is what gives something a lot of strength. So this actually is not a value of 5. It actually means that you have 5 times 5 times 5, which is a lot greater than the value of 5. So you would have 5 times 5 is 25 times 5. This would actually equal 125. 5, that's a lot of math, isn't it? Okay, so 5 to the 3rd is actually equal to 125. All right? Okay, so anyways, let's take a moment here, okay, and look at the next thing that they show us, okay? They now show us that each place in the place value chart can be written using an exponent, okay? So if we start out and we say we have 1, okay, in exponential form, 1 would be written as 10 to the 0 power, okay? If we have 10, it is written as 10 to the 1st power, okay? And we'll talk about these in a moment, but you can see there's a pattern. You have 1, you have 0. You have 10, you have 1. 100 would be 10 to the, count the zeros, 10 to the 2nd power. 1,000 would be 10 to the, count the 0, 10 to the 3rd power. Well, the next one in the pattern would be what? 10,000, okay? Count the zeros. How many zeros are there? There are 1, 2, 3, 4 zeros, so it is 10 to the 4th power. And then we have 100,000, and we have 5 zeros, so that would be 10 to the, anybody have it? Chris, somebody got it? Mr. Triola? Mr. Triola, anybody have it? Yeah, it would be 10 to the 5th power. Okay? So, that is basically what the book covers. It talks about the place value chart. It talks about how you increase going to the left, multiplying by 10. You decrease, you would divide by 10 if you went to the right. It then talks about exponents and how you can take a really big number and make it with fewer digits if you use exponents, okay? So now let's go on and talk about some of those weird powers of 0 and 1. Because this gets weird, okay? And when you get into pre-algebra and algebra next year, they'll go over this in greater detail. But there's a couple good rules to remember here. Okay, 10 to the 0 power equals 1. Okay, it's just 1. It is defined as 1. In other words, any number or variable, okay, variables are letters that represent numbers, any number or variable raised to the power of 0 except 0 equals 1. So in other words, if you have 2 to the 0 power, it will equal 1. That's its value. It's just 1. Power of 1, it equals 1. If you have 1 million to the 0 power, its value is 1. If you have A is a what? Does anybody know what this A is? It is a variable. It could represent any number. And any number raised to the power of 0 is 1. Okay? All right, now we get to talk about and look at raising a power to the power of 1. Okay? Now notice how we have 10 to the power of the 1 equals 10. 10 to the power of the 1 equals 10. So in this case, the rule is any number raised to the power of 1, 10 to the first power, or 10 to 1, power of 1, equals the number itself. Okay? So in other words, 3 to the power of 1 equals, anybody? 3. All right? 5,000 to the power of 1 is 5,000. B to the power of 1 is, does anybody know? Chris, does anybody know? Yeah, it is the power, it is B, okay? Power of 1 takes it to B, okay? All right, so now, what about 0 to the 0 power? Okay, a lot of times this is where it gets really goofy and crazy, and when you get older and, in the next level of math, this will make a little bit more sense, because 0 is undefined. 0 to the power of 0 gives you an undefined amount, okay? But just know that that's what you get when you raise 0 to the 0 power. It's an undefined, okay? All right, so these are some weird rules for the powers of 0 and the powers of 1, okay? All right, now let's take a look at some other exponents that are going to become very familiar to you in 6th grade. Okay? A number squared. Correct. Kids, show me a square using your fingers, right? Can you do it? Or how are they doing it? Are they all right, Chris? Yeah, a square. Everybody knows what a square is, okay? Now, a number squared. Some of you know what this is. This means the number is taken to the 2nd power, meaning 2 is going to be the exponent, okay? 5 squared, 6 squared, a squared, okay? That means that the 2nd power will be the exponent. 2 will be the exponent, okay, when a number is squared, okay? 5 to the 2nd power, okay? Here is a square, and what they mean is this. You have 5 times 5. This equals 5 times 5. So you have one set of 5, and then you have to have a total of 5 sets of 5. And when you square a number, you essentially are making exactly that, a square. So you'd have 5 going up, and you'd have 5 going down. If it was, say, 3 squared, you would have a square with 3 columns and 3 rows, which would give you a value of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 5 squared gives you a value of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 5 times 5 is 25. So, think of area. When you think of area, you're basically squaring things, okay? That's why they say square feet, square centimeters, square inches, okay? It means you're going to multiply some number, some base, by 2, okay? You're going to use it as a factor twice, okay? All right, so now that we know what they mean by a squared number, suddenly we can talk about a number cube, okay? That is cubed, okay? This means the number is taken to the third power. For example, 5 to the third power, okay? Well, at this point, we should know that we're talking about 5 being used as a factor 3 times, okay? And we already know that that equals 125, okay? But basically what we're saying is this. Now we have 5 along the bottom, 5 going back, and 5 going up. In other words, we have 5 times 5 times 5. 5 times 5 times 5. One of the most common ways, or one of the best ways to think about the power of 3 or cubing it, is to think of it as length times width times height, okay? Which gives us what, kids? Anybody know what length times width times height gives us? If something's squared, we're finding area. If something is cubed, we're finding, anybody? Think of volume, okay? We think of volume. All right, well, how are we doing, Chris? Are they still with us? Are they still with us? It's only been a few minutes, so yeah, okay. Let's give them some more information while we are going over this, okay? Let's give them a little bit more information, all right? Let's get this down here, okay? In your book, okay, back to your book, kids, okay, we want to look at the next page, okay, they have some other examples in your book. How do you write the expanded form of a number using exponents, okay? Now, there's expanded form, there's exponential form, and there's standard form. So you have standard, expanded form, and exponential form, okay? In this case, they give you a standard form. In the book, they give you 562,384, right? Okay, now, expanded form means that we want to make it bigger. Actually, you know, Chris, do you want to pause the video right now and make sure they understand what expanded means? Okay, why don't you pause the video and do a little something with expanding the form of something, okay? I'll just step aside and be quiet while you pause the video. Well, there we go. Did we go over? Okay, so they understand what it means to expand something. Okay, it means that you're going to change the way it's written, the way it looks, so that you can use it in a different setting. Okay, so expanded form. We would want to be able to use numbers in expanded form so that we could use them in different capacities. All right, so here's what we're going to do. Now, when you were younger, you learned how to write expanded form one way, but in 6th grade, you're going to write it another way. So if we're going to take this number and expand it, we're not talking about doing that, okay? We're talking about breaking down the value of each place value and writing it individually, okay? So in this case, you can see that 562,384 in expanded form becomes all of that, okay? Now, basically what it means is this. You take the 4, okay? The 4 is in the ones place. So you would have 4 times 1. 8 is in the tens place. So it's actually 80 because it's in the tens place, so that would be expanded to 8 times 10. Then you have 3 in the hundreds place, so you would expand that to 3 times 100. Now notice that you're adding all of those amounts as you go, because each one of these place values represents its own value expanded. All right, so then you get to the 2, which is in the thousands place, so you would have 2 times 1,000, because you have 2 sets of 1,000. All right, and you want to make sure you add that to the other amounts you have. So then you go into the 10,000s place, and you have 6 times 10,000, which is quite a bit, and then you would add that to all the other values that you expanded. Then you have 5 in the 100,000s place, so you would have 5 times 100,000. So basically, expanded form means that you take each of these digits and you rewrite them based on their place value, and then you add them all up together. Now you do that because there will be situations where you want to understand very definitely what the value of each digit is, not just as a part of a whole number, okay? So, that way you don't think, oh, that's just 5. No, that's 500,000. This 5 is 500,000. That's a lot, okay? Now, this is kind of how you learn to do it when you're in 5th grade and 4th grade. We're going to get rid of some of the zeros, and we're going to write it in expanded form using exponents. So in other words, we're going to count how many zeros we have. It's a multiple of 10, and we're going to rewrite these to a power, 10 to a power, all right? So it'll look like this. We start with the 4 times 1, okay, 4 in the ones place, which would be 4 times 10 to the 0 power, because we know that 10 to the 0 power actually has a value of 1. Okay, so we actually learned about that way back up in that slide right here. Okay, 10 to the 0 power has a power of 1. That's why it works when you write it in exponents. Okay, so anyways, we have 4 times 10 to the 0 power. Okay. Then we go on and we work with the 8 in the tens place. So we have 8 times 10 to the first power, because we want to have 10 here because it's 8 times 10. So we have 10 to the first power. 10 to the first power equals 10, okay? Or a number to the first power equals itself. Then we go into the 3. So the 3, okay, is in the hundreds place. Well, in order to get 100, you have to do 10 times 10. So we have 10 to the second power. So we would write it as 10 to the second power, 3 times 10 to the second power. And then we go on into the thousands. Well, we have 3 zeros, so it's 10 to the third power. That's what we have. 2 times 10 to the third power. 10 to the third power represents 1,000, and the 2 is just 1,000. Okay? And so we would keep going all the way up until we get into the 100,000s. Again, the 6 is in the 10,000s place. 10,000 can be written as 10 to the fourth because there's 1, 2, 3, 4 zeros. And then we have 5 in the 100,000s place. That can be written as 10 to the fifth power because we have 1, 2, 3, 4, 5 zeros and that. And so once you have the expanded form broken down by place value, you then can add them all up. Okay, so don't forget to put your addition symbols in there in between the multiplication operations. Wow. How are they doing, Chris? They doing all right? Yeah, they look like they might be a little bit tapped out at this point, okay? let's just real quick go through the explain it, okay? How many times is 9 used as a factor in the exponent 9 to the 8th power? Okay, think about that, kids. How many times is 9 used as a factor in the exponent 9 to the 8th? Anybody want to give that answer? All right, well, hopefully we have an answer. If not, I'm going to show you an answer. Well, remember, 9 is your what? Base, and 8 is the exponent, right? 8 is the exponent, which means that you will use 9 as a factor 8 times. In other words, 9 to the 8th power is going to be 9 times 9 times 9 times 9 times 9. That's 5 times 9 times 9 times 9. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. Woo! That's a lot. Okay, next question. Why does 3 times 10 to the 0 equal 3? Why does 3 times 10 to the 0 power equal 3? Well, that's because 10 to the 0 power equals 1. So 3 times 10 to the 0 power would equal 3. It would be the same as saying 3 times 1 equals 3. All right? Okay, Chris, Mr. Triola. Do you want to keep going? You want to do some review or practice problems, restroom break? What would you like to do? Okay, I'm going to let your teacher decide whether we go on or don't go on at this point. But if we're going on, we're going to start the next video, which would be a practice video. Okay, so we're going to just kind of call it quits on this video. That's a lot of information to take in. If we're going to keep going with this lesson, we'll keep going. All right, bye-bye, kids.